Hello there, this is Professor Roldan with Intermediate Algebra, section 14.4. This is the start of the second part of chapter 14, as we have just finished the first part. So this second part is only two sections, 14.4 and 14.5, and so you can expect the exam to come quickly, as this is only two sections. So let's get started with 14.4, addition, subtraction, and more multiplication of radicals. Alright, so first of all, let's think about what this actually means here. 5 plus radical 2. And basically, you really can't add those together because they're not the same type of number. Okay, at least the way they look now. So they can't be added because they are not like terms. Okay, so now how could we get these to be like terms? We would have to change the radical 2 to some type of real number, so or rational number. So it'll be 5 plus, we'll type this in our calculator and then get a decimal and have to round it off to a rational number. So then we can add those together to get 6.414. Alright, so this is what we're going to be doing, not turning anything into decimals, but we need to make sure that our terms are like. So before we do that, let's talk about, again, review how to simplify. Okay, so simplify, review. So you guys know how to do this, but let's take a look at it. So when you have a number in front, a number outside, a number inside, you can't multiply those, but you do need to say, well, can the 8 be turned into a radical, does the 8 have a perfect square factor inside? So we can break that 8 down. So yes, it does. 4 times 2, that's going to make that 4 turn into a 2. So notice everything is times. So when this 4 comes out as a 2, square root of 4 is 2. Now we got that 6 out there. And then the 2 stays inside the radical. And then we simplify the outside to get 6 radical 2. Okay? So go ahead and try B and see how you do. So pause the video, work it out, see what you get, and unpause it and see the results. Alright, let's see how you did. So radical 50 can be broken down into radical 25 and 2. And then we chose that because 25 is a perfect square, which divides into 52 times. So we make the 25 a 5. And then this 6 that was here from the beginning stays there until it gets multiplied by another number. So 6 times 5 would now be 30. And this radical 2 just kind of just stays in there. Okay, let's try one more. Letter C. Go ahead and try letter C and see what we get. Alright, let's see how you did. 60 can be broken down between 4 and 15. Now, just in case you forget how to do that, or you're not sure what the numbers to put, you can break down 60 into perfect prime factors. So let's just say you knew 6 times 10. Oh, great, write it down on the side. Don't write it here. And then break down this 6, 2 times 3. Break down the 10, 2 times 5. So this is going to help us know what to put here, because as you can see, we get 2 times 2. That's our repeated number. That's our perfect square right there. And then 3 times 5 is going to go inside this other one. So then this becomes a 2, and he stays inside. Okay, or you can go straight from here as well. So always factor. If you can't think of it, usually break it down into prime factors. Okay. Now, of course, the other way is to look for perfect squares. So divide by perfect squares. So you can divide by 4, 9, 16, etc. And if you would have divided by 4, you would have gotten the answer pretty quickly. Okay, 60 divided by 4 would have been 15. Okay, now let's step back and look at the big picture here. And as you can see, we simplified 3 different radicals, but only, if you look at the results, only 2 are like. And because they are alike, then that means we will be able to add them or subtract them. Okay, so this is what we're going to be doing in the next section. Okay, so now let's take a look at adding and subtracting. Now, the easy part about this is when the radicals are already like. Okay, so that's kind of like what we looked at right here. These are like radicals because they're both square roots of 2. So if you look here, these are both alike because of the radical 5. Okay, so you can treat them like an x. So this one here is similar to 3x 3x plus 5x. Oh, sorry, 4x. And we would say this is 7x. Okay? Well, here we have radical 5 as our like factor here. So we're just going to be adding 3 plus 4. Okay? So again here, we can do the same thing. We have radical a's, so that means we can do 2 minus 17, which is negative 15 radical a. Okay? Okay, so why don't you try this one? Okay, hopefully you didn't write any numbers, because this radical 3 and radical 2 are not like. Okay, it's kind of a trick question. Those are not like, so we cannot add those. So can't be added, and it's already simplified. Okay, so let's take a look at D. Well, you say, okay, these are not like either, so we can't add them together. Well, it's not entirely true. They are not like right now, and this one's pretty much done. You can't simplify that one, but if you look at the 18, that 18 has a perfect square inside of it. Okay, hopefully you're thinking of not 1 times 18 or 3 times 6, but you're thinking of 2 times 9. this 18 does have a perfect square inside. So we're going to do so we're going to, on the side, I recommend that you do this on the side. So this is going to be radical 9, radical 2. This becomes a 3, radical 2. And I'm just going to put that answer right over here. And now we see that they are alike. So I'm going to put those together and get 2, radical 2. Okay, let's check out E. Again, this looks simplified, this radical 3, but the 27 can be broken down. So we're going to break that 27 down between a 9 and a 3. Right, 9 times 3 is 27. And so now this radical 9 becomes a 3. That's what we did at the top. So then these two become 15. So I recommend doing the scratch work for simplifying the radical on the side. And then when you're done, we're going to bring this back up here. So let's say, so this guy's going to come up here. And we're going to do plus 15 radical 3. And as you can see, they are now like radicals. So that means we're going to go ahead and put these two together, giving us 3 radical 3. Okay, so why don't you try F and give yourself some time and pause the video and then come back and see what the result is. Okay, well here's F, and hopefully you worked on the side and broke down the 54 to 96, got a 3 out of that, multiply to get 21, and then brought this work up here so that you could finish this work here. 21 minus an invisible 1 right there, which is 20. Okay, so if you have any questions, let me know. Let's take a look at G. All right, let's take a look at letter G. G has 3 parts, and each of these parts we're going to have to simplify. As you can see, there's a perfect square in 8, in 72, and in 98. You may not realize the 98 or the 72, but they're there. Okay, so we're going to go ahead and work under. Since we have to do everything, we have to simplify every single term anyway, so we can just go ahead and break up the 8, break up the 72, and the 98. Okay, so a good place to start would be to divide each of these numbers by 2. So in other words, 8 divided by 2, that's going to be 4. And that's the number we need. There's a perfect square. 72 divided by 2, that will be 36. 36 is a perfect square, so we're going to use that here. And 98 divided by 2 is 49. And that's a perfect square, so we want to use that. Okay, so if we didn't get a perfect square from dividing by 2, then you want to divide by 3 and so on and so forth. All right. So each of these have been broken down. And what we're going to do is take the square root of each of these perfect squares. So 9 times 2 minus 6 radical 2 plus 7 radical 2. And all we have to do is put this one together right there. And we're going to be putting these three numbers together because we have like terms. So 18 minus 6 is 12, and 12 plus 7 is 19. All right. Okay, so basically the name of the game is simplify the radical before we can add or subtract the coefficients, or the radicands, I could say. So let's go to the next page. Okay, so for the try these page, try all of these. You're gonna be responsible for these on your own. I'm gonna be checking to make sure you're tracking when we are in class. The only one that I really want to go over as a review would be D. So this one. So all of these, okay, have it ready. For class. And you can try D if you want, but I'm going to review D in class. Okay, I'm not going to be going over the other ones since I've already spent time on the video. Okay? So let's go to the next page. Okay, let's take a look at page 3. Page 3, so we've done addition and subtraction, so page 3 is going to be multiplication. Alright, we will get to division at the end. But for now, basically part 2 of this study is multiplication of radicals. And just to do a quick review or reminder of the different scenarios that we get in multiplication, we have this strategy, which is to just distribute things on the outside to the inside parentheses. We have, and that'll give us 6x minus 8, for example. FOIL, which is first, outer, inner, last, and that just means to distribute 4 times. Okay, every arrow has a name, so first arrow is the F, front terms. Second arrow is the O, the outer terms. Third arrow is the I, the inner terms. And the last arrow is the last terms. So in this case, that would give us 3x squared minus 21x plus 2x minus 14. And it's going to translate to, you got like terms right here. So it's going to be 3x squared minus 19x minus 14. Okay? And of course, what do we do with this? This has a power of 2. So I'm not going to work it out, but I do want to say, hey, doesn't that mean there's 2 of these? Two identical binomials with the power of 2 means there's 2 of them. Okay, and we could multiply those out. Now, there's another thing I want to point out to refresh your memories, and that is the concept of outside versus the inside. In other words, the coefficient versus the radicand. Okay, those are 2 separate types of numbers. They can't be mixed. And so it can be multiplied. And so when we do multiply two of these, we can do outside times outside and inside times inside numbers. Okay? So we can't do, we cannot mix up the outside and inside. So I just want to remind you of that because we're going to see a lot of that in the next couple examples. Okay, so let's take a look at the first example. We're going to do radical 3 times radical 5. Those are both inside numbers, so I can definitely do 15 here. And then the next two, radical 3 is an inside number, negative 1 is an outside number, so those are going to stay separate, and I don't need the 1 because the 1 is invisible. Okay, let's do the two binomials over here with FOIL. So these two right here are two outside numbers. That's going to be 10. These two right here, the 2 is an outside number and the 7 is an inside number. So I can't multiply those two. So I'm going to get 2 radical 7. And then the inner, same thing, outside and inside. Keep those separate. And then the last product, or the L of FOIL, is there are two inside terms. So we can do inside numbers. So we can do 3 times 7 is 21. Okay. So since there are no like terms, this is done. Basically, we can't simplify anymore. Okay, so we're basically done. With those. Alright, so let's take a look at what happens when we have a power of 2, which means that we need to repeat this. And then we need to go ahead and multiply. So 3 times 3 is 9. Outside 3 times inside 5, can't do that. Same thing here. And then the last term is 5 times 5, because those are inside numbers. Negative times negative is positive. Those are the outside numbers. And then we have some like terms right in the middle. And we have a perfect square right here. So there's some more things that we need to do here. So this is going to be 9. That just comes down. Negative 3 and negative 3 make negative 6 radical 5. Those are like terms. And then we have a perfect square, which becomes a 5. So we still can actually add these two up right here. So final answer is going to be 14 minus 6 radical 5. Okay. So there's kind of a lot going on there. You'll have a chance to practice on your own in a minute. Let's do one more over here. So these were the same, okay, and these are different. And this is kind of introducing you to the concept of the conjugate, and we'll see what happens again with this, as we've seen before, but this time with radicals. So let's do FOIL here. So that's going to be 9 plus 3 radical 5. Then inner and last, it's going to be negative 3 radical 5 minus square root of 25. Okay, so we can, same thing. Now, the two middle terms this time are not going to add up. They are going to cancel because that is 0. So that's the difference between the two problems that we just, between C and D. So the two middle terms cancel out, leaving us with just a minus 5, okay? And then 9 minus 5 is 4. So I do want you to see the difference in the answers here. Okay? Notice that here there's a radical, and here there's no radical. And that's going to play a significant role in one of our strategies for division, where we don't want radicals in the denominator. And so the strategy is going to be to do what we have just done in part D. So this is going to be the strategy for division in the next part. Okay? Because there's no radicals in our answer. So we'll see the benefit of that a little bit later. Okay, so what you want to do now is try these on your own. Okay, make sure you have these ready. So basically have these two ready for class to be checked. Make sure you're tracking. And the ones I'm going to actually go over in class will be C and D. Okay, just to summarize the multiplication part. Alright, so go ahead and work on that. You can work on all four if you want, but I'm going to be reviewing C and D in class. Alright, now we've reached the last part of our study here, which this part has to do with division. Okay? And you're going to notice the fraction bar, which is the division sign. And there's really nothing to do except for to rationalize, okay? Now, again, we saw the differences between having the same exact terms and having almost the same exact terms but with different signs. So notice the only difference in these are the signs. Okay, everything else is the same. So conjugate conjugates are basically the same terms except for the middle part. Okay? Except for the sign in the middle. And the benefit of conjugates is that the two middle terms always cancel out. So, real quick, let's see how these cancel out. Let's do FOIL, and we're going to get 4x squared minus 6x plus 6x minus 9. And as you can see, middle terms cancel out. Okay? So you can actually skip that part and go straight to the answer if you want. Same thing on the other side. Now this is the more relevant part because these have radicals. So these two will be radical 9. These would be positive radical 3x. They're both inside terms, inside numbers. Same thing here, except this is minus, sorry. And the last one will be x minus x squared. So again, these are conjugates, so guess what? The middle terms cancel out, leaving us with just these two perfect squares right here. 3 minus x. Okay? So notice that there's no radicals in that in the answer when there's conjugates. So this brings us to our strategy here. When we want to rationalize the denominator, we're taking this irrational number. So this right here, this is what's called the irrational number. And we're going to rationalize it. That means we're going to make some type of whole number or fraction or something that's not irrational. And basically the strategy for that is to use conjugates. Why? Because you can see here, all those radicals that we had in the problem, they pretty much disappeared. Okay? The two in the middle disappeared completely, and the other ones were perfect squares, so those also disappeared. So this is what we're going to do here as our strategy. So, hey, so no radicals in the denominator as we have seen before. Okay. So we got to get this radical 5 out of here. And we're going to do that by multiplying by 1 in the form of conjugates. So we're allowed to multiply by 1 because ones do not change anything. But we're going to multiply by the conjugate. So there's my 1. Okay, anything divided by itself is 1. So okay, so this is our strategy here. And distribute those two. So this is the easier part. That's 6 minus 3 radical 5. Okay, not too bad. But the bottom we have a binomial times a binomial. So we have the 2's. 2 times 2 is 4. And that's going to be negative 2 radical 5. And these two are going to make positive 2 radical 5. Well, we expected that to happen. And then the last one will be minus radical 25. So the top is pretty much simplified. It's the bottom we got to worry about. So remember, the whole point of doing conjugates is that my radicals disappear in the middle, and this radical is going to disappear from the end here. Okay, because we know that's a 5. So basically we have 4 minus 5, and there's the radicals completely gone from the bottom. And now we finish this. Actually, we have a couple more steps. So the only thing we can do is 4 minus 5 is negative 1. And then we got to separate the negative 1 to both terms here. So that's negative 6 plus 3 radical 5. Okay, so I know that's a lot to take in. Again, this is why we split up this chapter, so we can really talk about and focus on this technique. So again, just to review, we used the conjugate of the bottom. And we do the same thing on the bottom and on the top. We're going to distribute on the top, creating those two terms. We're going to do FOIL on the bottom. Okay, so we know that the O and the I of FOIL is going to cancel out because these are conjugates. So really, all you have to focus on is 2 times 2 is 4. And then 5 times 5 with the minus is square root of 25. This becomes 5. So now the whole point of doing this is to make 4 minus 5 right here. Okay, the top over here stays the same. Get negative 1. And then negative 1 divided into 6 is negative 6. And negative 1 divided into 3 is positive 3 right here. Okay, this is the final answer. Okay, so let's do another one together. We're going to do B. So, again, I want to multiply by the conjugate. And it's only the denominator, okay? So we're going to do the opposite of the bottom. Or not the opposite, but the conjugate. Okay, so we can put these parentheses if that helps. And then we're going to do. So radical 9. These are all inside numbers, so we can multiply all of them. So that's going to be radical 15. Another radical 15. And a radical 25. Okay, that's FOIL on the top. Let's do FOIL on the bottom. Which, remember, we can go ahead and skip the O plus the I of FOIL because we know it's going to go in, it's going to get canceled out. So I'm just going to do the F of FOIL minus the L of FOIL. Okay, so the front terms I'm going to focus on, that's radical 9 minus the last terms, which is radical 25. And just put the minus in between. Okay, that'll shorten up the work a little bit. Okay, so now we have perfect squares right here, right here, right here, and right here. And these two we need to put together. So I'm just going to work down this time. So the square root of 9 becomes a 3 on top. 2 radical 15, that's 1 plus 1, so that's 2 radical 15. And then the 25 becomes a 5. That's the top. And then the bottom is going to be 3 minus 5. Okay, so we need to put these like terms together right here. And these two. So 3 plus 5 is 8. And then 3 minus 5 on the bottom is negative 2. So basically, we divide both of these numbers by the negative 2. And I'm just going to go ahead and split that up for you. And our final answer then is going to be negative 4 minus 1, which I don't have to write, radical 15. Okay, so this is example B. Let's just go over this one more time. I use the conjugate of the bottom. Okay. So it looks the same, except this should be minus, this should be plus. And the reason for that is I want those two middle terms to cancel out. But in the top, we have this big mess here. So make sure you do your FOIL right. Okay. 25 and 9 are perfect squares. These two, it's 1 plus 1 is 2 radical 15. That's the top. The bottom, we're just going to do 9 and 25 with a minus in between. That's the first minus the last. And then we have 3 minus 5. 3 plus 5 is 8. Bring this guy down. 3 minus 5 is negative 2. And then divide each of those numbers by the negative 2. And we get our final answer right here. So for C, I do want you to skip this one. I don't really like this one. I think it's confusing, so I'm going to skip this. Okay, and then the one that looks just like it on the next page. Which is down here as well. So go ahead and try A. Go ahead and try A on your own. I'm going to pause the video so you can check your work. Okay, give you a chance to do it. And then the next one we're going to do in class, okay? So try now. And then you can try the next one in class, but I'm going to go over this one in class. Okay? So let me go ahead and start you off with this one. You're going to do 3 minus radical 11. And then go from there. Pause the video and see how you did. Okay, let's see how you did. I got negative 6 plus 2 radical 11. And basically did the conjugate of the bottom. Multiply the top over. And then the bottom was just 3 times 3 is 9. And then 11 times 11 is 121. Now you can actually skip that part. You can just write 11 because you know we have repeating numbers under a radical. So you can actually just go from here to here in this step if you want. But I just like to do it for demonstration purposes. Then 9 minus 11 is negative 2. And we want to go ahead and divide the two coefficients by the denominator since they can be divided to get whole numbers. So we get negative 6 and positive 2 right here. All right, well, take some time practicing that. We're going to review the next one in class. Alright guys, well, this is 4.4. We will review this in class and get started on the next section in the next class. So see you in the next video. See you in class. Take care.